Okay, we're gonna relate polynomials to profit. Okay, the cost to produce items was $300. Doesn't matter what the items are. It cost me $300 to make them. Then when I sell them, I make $700. Now, what's the profit? What's the money I really made? Well, you take the money you made minus your cost to produce them. So you really just made 400. You didn't make 700. You made 400. Now let's say the cost to produce is 100. Now when I make the money, okay, I make less, but it costs less to produce it. So that should cancel out. And 500 minus 100 is $400. So I can get the same profit even though I make less money. Okay, because then the cost to produce it becomes less. So that's how there are more than one ways to. There's always more than a way to make this a profit of the same. Okay, so I got $400 profit 2 different ways, and there's many different ways you can make a $400 profit. Now, let's go right here, and I got 4 of these to do. And you have you have this little bit different type of story problem in that the equation's right here. One of the costs to print novels can be modeled by the equation c equals x to the 3rd power minus 10x to the 2nd power plus 28x, where x is the number of novels produced in thousands. The company produced 5,000 novels at a cost of $15,000. What other numbers of novels produce the same amount? Okay, means what other novels could I produce rather than 5,000 to have the cost be 15,000? Okay. Now what we do is we use this given equation, write it out. The guy's not showing their work the way I want it. Don't complain to me why you're not doing well on assignments. Okay. All right, now, once you get the equation, you come over here and write what your variables represent. So c is the dependent variable, x is the independent variable. Okay, c is your money amount. Okay, it says c is the cost. Okay, so that's going to be your money amount. Okay, just put it above it. Then x is whatever we're producing. It didn't say what we're producing. Oh, it's novels. Okay, so novels. Now it gives me two values to put in for those at the same time because they're in the same sentence. So 5,000 novels. Now since it's in thousands, you can just use 5 for novels. And the cost is 15,000, but you're just going to use 15 because it's in thousand. It means you don't need to have those extra zeros when you put the value in. Okay. So I want you to put those numbers in at the same time. I want you to replace your c with 15, and then I want all these x's replaced with 5s. Okay. So 5 to the 3rd minus 10 parentheses 5 to the 2nd plus 28 parentheses 5. Now make sure that equals 15. Just verify. If it doesn't, you got something wrong. Parentheses 5 to the 3rd minus 10 parentheses 5 to the 2nd plus 28 parentheses 5. Looks like it's 15. Now, what we're trying to do is keep the cost at 15, but we want to find out other amounts of novels or other x's that can give me 15. So this will go back into an x to the 3rd minus 10. That'll go back into an x to the 2nd. Plus 28 goes back into x. So there's 3 roots. So go down here and put 3 roots. So what do we have? Well, we have x to the 3rd, obviously. You have x to the 2nd. You have x, and you got the constant. So that's going to be 4 terms. Okay? So you take out the 15. You need to get that over all together. Okay? And now I have 0. Okay? So I have x to the 3rd power minus 10x to the 2nd power plus 28x minus 15 equals 0. Now, here's the beauty of this. You're like, oh, 4 terms, grouping. No, we ain't even got a factor. Since we have one answer already, okay, that answer was 5. We already have one of the roots right there. So since I have one of the roots, I don't need to use a rational roots theorem, okay? I go right into my L, and I can divide by that 5, okay? because 5's already one of the ways to make $15,000. So then I have 1, -10, 28, and -15. So you drop your 1. 1 times 5 is 5. -10 plus 5 is -5. -5 times 5 is -25. Gives me 3. 3 times 5 is 15, which gives me my remainder of 0. Okay, cross that out. Now, the new equation that used to be 1x to the third, well, now it's a 1x second minus a 15x plus a 3, and you can just put equals 0 now. Okay? Now you're down to x second, x, and the constant. Okay? So that's 3 terms. Well, I know how to solve 3 terms. That's GCF and T. Okay? So I synthetically divide by the answer I was given. That gets me down to an x squared x constant, okay? And then I would apply my quadratic equation solving method. So there's 3 terms. So GCF. You don't have x, you don't have a negative, it'd just be 1, so don't do it. Okay, 1 times 3 is 3. Positive. Negative times negative. It's got to add -5. Well, 1 and 3, that's too small to be -5 right there. It's -4, so write QF. That's a quadratic formula. So, opposite of B, plus or minus D square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So we know that A is 1, okay? So we got 5, 2 times 1 is 2. Now the B is -5. 4A is going to be 1, C is going to be 3. So you apply the square root onto your calculator. So you got -5 to the second minus 4, 1, and 3. Okay, 3.61. So I take 5 plus 3.61 and divide by 2. I got 4.31. That's 4,310. Okay, you don't need to write that, but that's what it is since it's by thousand. The -5 minus 3.61 divided by 2. Or no, 5 minus 3.61 divided by 2, 0.70, so that's 700. Okay, all those are legit answers. Just put K behind them because it's per thousand, and put novels. Okay, that's the number of novels that could cost that much. Okay, next problem. The profit P in millions of dollars of a shoe manufacturer can be modeled by the equation P equals -21x to the third power plus 0x plus 46x. X is a number of shoes produced in millions. The company now produces 1 million shoes and makes a $25 million profit. They'd like to cut back on production. What other number of shoes will yield the same profit? So you write your equation. By the way, that 0 is x to the second. I didn't put that there. 0x to the second. Now you're like, what's with the 0? I put that there so you wouldn't forget it. Plus 46x. I forgot to put the second power, though. That's my fault. Okay, what do your variables represent? Okay, the dependent variable is the money. And then x is whatever you're producing, which is shoes. Now they're both by millions. So the amounts I'm given, that's a coordinate point. 1 million shoes, just put 1. You don't need to put the zeros after it because when it says it's in millions, you can just get by with 1. And then $25 million profit. Now put those in at the same time for verification. Okay, make sure that equals 25. It is. Okay. I want to keep the profit at 25, but I want to change these ones and find out other X values that can result in a $25 million profit. So there's 3 roots, and we already have one of them. What's the number we just had in a second ago that gave me 25? 1. So 1 is your first answer. So you got an X third with an X to the second with an X with a constant, okay? Technically you don't have an X second, but it's there, okay? Now, so you need to get everything to one side, so that constant's got to be moved over. Just go at the end. So we got negative 21x third plus 0x second plus 46x minus 25. I usually put the equal 0 there. Now don't waste time factoring. When you already have a solution, synthetically divide by that solution and then line up your other stuff. Negative 21. Now this is why I have the 0. Because technically the 0x squared wouldn't be there, but we'd still have to account for it with 0. That's why I put it, so you wouldn't miss it. Because if I would have taken that out, a lot of people would have just lined up, skipped over the x squared. You can't do that when you synthetically divide. So negative 21 times 1 is negative 21. Then you add negative 21 times 1, negative 21. Then you add, you get 25. 25 times 1 is 25, gives me my remainder 0. Now what's the equation? Well, it's negative 21 from x to the third to x to the second minus 21x plus 25 equals 0. If that's a remainder, you can put 0 on that. Now you're down to x to the second. Now you've also got x to the first and the constant. So that's 3 terms. We solve those with the GCFT. Okay. Okay, there's no x there. There is a negative in front. Okay, 21 and 25 is just 1. But I'll do it because it's negative 1. Okay. But it doesn't have an x, so I don't really need to worry about it as far as finding the roots. Okay. If it's negative 1x, I'd line that up. But 21x to the second plus 21x minus 25. So 21 times negative 25. Negative 525. What did I tell you about numbers in the hundreds? Don't go to the quadratic formula. So plus or minus, opposite of b, e opposite of b, e plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a, over 2a. So the opposite of 21 is negative 21. b, 21. A is going to be 21. C is negative 25. You got to make sure you get it in as negative. Okay. And A is 21. So you know you got the negative 21. You know under it, 2 times 21 is 42. Plug the square root into your calculator so you don't make little mistakes. Okay. So 21 to the second minus 4. 21, negative 25. Okay, I got 50.41. And then I evaluate the rest of it. Remember to click equals after you add. You can't just do both operations on the same screen when doing this. Divide by 42, 0.7. 0.70 if you want to get more exact. Then negative 21 minus 50.41. Divide by 42, negative 1.70. Cross out the negative. You don't use that as an answer. So it's just these two. Okay. So you put millions this time because it's in the million. And it's X is shoes. So 1 million shoes. 0.7 million shoes, which is 700,000. Okay, next problem. The profit P in millions of dollars of a manufacturer of iPods, should say iPads actually, can be modeled by P equals negative 4x to the third power plus 12x to the second power plus 16x where X is the number of MP3 players produced in millions. Okay, I got a bunch of crap written. It's supposed to say iPads here. Nobody makes iPods anymore. Wouldn't be MP3, it'd just be iPads. Didn't write this. Currently, the company produces 3 million iPads. It makes a profit of $48 million. What lesser number of iPads could be sold for the same profit? Sorry about the bad writing. So there's your equation. P equals negative 4x cubed plus 12x squared plus 16x. Okay. Now, what do those variables represent? Okay, P is a profit. Okay, so that's money. And X is what you're producing, which is iPads. Now, they're both in millions, so whenever they give me in a quantity of 1 million, I can just use those numbers. So 3 million iPads, 48 million profit. Now, put those in at the same time to verify that that's actually a solution, because they give you a solution. 3 to the third plus 12 parentheses 3 to the second plus 16 parentheses 3. Roll that in, make sure it equals 48. Yep, sure does. Okay. Now I want to keep this at 48, but I want to find other x's that can give me that value. So x has 3 roots, and you already know one of them. Okay, you were just given one of them. It'd be 3. Well, since we have x to the third and we have x to other powers as well, okay, that tells me we need to line up everything on one side. Now, why would we waste time grouping when we already have an answer that we can synthetically divide by? So we have negative 4x cubed plus 12x squared plus 16x minus 48 equals 0. Okay, so I'm not going to waste time grouping because it's probably not even going to work. Okay, I think this one actually would, but not most of them don't. So I synthetically divide by 3. So we have negative 4, 12, 16, negative 48. Negative 4 times 3 is negative 12. You add that, that's 0. That's not a bad thing, that's a good thing. 0 times 3 is 0. 16 plus 0 is 16, times 3 is 48. And you get your remainder 0. Okay? Now, it was x to the third, so now it's x second. Now here's a beauty. You have 0x. Well, you can take that out if it's 0. Okay? And then you have a constant of 16 equal to 0. Now here's a beauty. You just have x squared and the constant, okay? So if I don't have the x and I just have x squared and the constant, I'm not going to be using the GCF table and all that, okay? I'm going to use linear properties followed by the square root, okay? So linear properties means you just undo your plus 16 with a minus. That'd be negative 16. Now I divide by negative 4, and that's 4. Now I apply the square root. That could be 2 or negative 2, plus or minus 2. So 2, negative 2. You don't need your negative, okay? So again, if you have x squared, but the x to the first is gone, and you just have the constant, you don't want to sit there and try to factor it or use a quadratic formula. You apply linear properties. That's when you get rid of the operations to the x squared, then you do the square root, okay? So 3 and 2, label them in millions. The product I'm selling is iPads. Right there. So if that x, it becomes 0. That's not a bad thing. Okay, the profit P in millions of dollars for a t-shirt manufacturer could be modeled by P equals negative 1x cubed plus 4x plus x. X is the number of t-shirts produced in millions. Currently, the company produces 4 million t-shirts and makes a profit of $4 million. What lesser number of t-shirts could the company produce and make the same profit? So you write out the given equation, negative 1x third plus 4x the second plus x. You're going to want to put a 1 there. Okay, now, right off this side what the variables mean. So P is your profit, that's your money, and X is the items. In this case, it's going to be t-shirts. Okay, so in the same sentence, they say 4 million t-shirts, so I just put a 4, is a profit of $4 million. I put a 4. Now, the P is 4, and then I substitute 4 in for all the X's. Okay, now verify that into the calculator. It's 4. Okay, so it's you can check it. Okay, it's verified. So I want to keep the profit at 4, but I want to find other x's that give me 4. So negative 1x to the third plus 4x to the second plus 1x. So there's 3 roots, but we've already been given the first one. First one was 4. It's what I had in just a second ago for x. Okay. Again, that's your first solution. Now, get your others. Well, you got x third. You got x squared. When you have x to all these different powers, you're going to have to move everything to one side. Okay, so that's now 0. So anytime the variable you're solving for is to different powers, you need to clear it and get it equal to 0. There's 4 terms, that's true, and maybe grouping will work, but why would I do that when I could save a lot less time by dividing by my first answer? So negative 1, 4, 1, negative 4. And you're like, RRT, you don't have to do rational roots theorem. They gave me the answer. Okay. Negative 1 times 4 is negative 4, and then we have that 0 again. 0 times 4 is 0. It's 1. 1 times 4 is 4, and you get your remainder 0. Okay, so the negative 1 used to be an x to the third, now it's an x second. The 0 is the x, the 1's a constant, and you can set that equal to 0 just like this one was at top. But the 0x, get that out of there. So now I have x squared, and I just have the constant. I don't have x to the first power. It was a 0, I got rid of it. So again, x squared and the constant. Now if it's x squared, x and the constant, I should see a GCF table go up and possibly the quadratic formula. Okay? With just x squared and the constant, we just use linear properties followed by the square root. Okay? So get rid of your plus 1 with minus 1. Linear properties, you get the non-x's to the other side. Okay? You don't move everything. You divide by negative 1, that's 1, and you apply the square root. Square root of 1 is 1, but it could be the positive or the negative anytime we square root. So 1, negative 1. The negative is not a viable solution in the context of a story problem. So I label these millions. And as far as your label, well, X is t-shirts. 4 million t-shirts. They told us that, but I've later discovered that producing 1 million t-shirts would also give us the same profit.